Hello everyone. Welcome to those of you joining us online and to those here in Russell Labs. Thank you not just for coming but also for participating, as I plan to talk only for 35 minutes, leaving about 20 minutes for questions at the end. And for those of you online, please feel free to comment and discuss on the YouTube page below. Because my time is limited and my audience is so diverse, I've decided not to share everything I did in my research. Instead, I'm going to do two things today aimed at two main audiences. Firstly, I'm going to share my most salient findings for those of you vested in landscape conservation. And secondly, I'm going to describe my methodology or approach for those seeking to understand and improve shared decision-making across expertise areas or disciplines. I hope to share enough for you to make judgments about the usefulness of this approach in other contexts. If you want to learn more in detail, please feel free to read the executive summary or my thesis itself. Or better yet, let's go grab a beer at the terrace and I'll tell you all about it, plus the findings that didn't make it into the thesis. My contact information is available on the executive summary you received as you came in, and you can download this summary via a link on the Google event page for this talk. I must confess the title of my talk may be misleading, as though only some landscapes are multifunctional. In reality, they all are. The challenge is sustaining this multifunctionality over time. We can recognize a plethora of resources people are using in multifunctional landscapes, such as the one pictured here, including natural resources, social resources, economic resources, and resources that integrate all of these. Though we commonly think of these functions as separate from each other, experience shows us they are intimately connected. Moreover, they are changing over time as both natural and human systems interact. This makes the landscape a complex, adaptive, social ecological system. Complexity stands in contrast to a sophisticated machine, which is merely complicated. Complicated systems can be broken down into their parts and put back together again with the same functions as before. Complex systems, on the other hand, are completely different. Their parts are connected through nonlinear dynamics that make the system irreducible, with emergent and surprising properties that we cannot predict. Experience shows, even here in Wisconsin, that we are still learning how to manage complex systems such as landscapes. Mixed public and private ownership increases the challenge of sustaining multifunctionality across landowner boundaries. Two brief examples will illustrate the variety of challenges we're facing. Oak wilt is a devastating tree disease that has been spreading across the central United States, including nearly all of Wisconsin's oak landscapes. It ignores landowner boundaries as it kills entire stands of oak in the circular patterns pictured here. The spread of oak wilt is a systemic disturbance that will slowly push oak ecosystems and industries to a tipping point. How such diseases, pests, and invasives spread and impact landscapes depends on many interacting variables, such as landowner tenure, that are changing slowly but inexorably. Oak wilt is a complex landscape issue to which we have not yet responded adequately. And last month's record rainfall reminds us erosion and flooding are enduring issues on hilly landscapes. But in the long term, these are not simple or even complicated problems. Rather, we realize that the placement of roads and towns is a planning issue also related to culture and economic development, and that planting rows of corn and soybeans on steep slopes lies at the confluence of conservation practices, forest management, and the economy of commodity crops. Erosion and flooding are complex landscape issues emerging from the connections between many landscape functions that change slowly, then become an acute issue when the rains fall. I could list 1,000 other examples for mixed ownership landscapes, some good and others bad. Biomass market developments, ironic budget surpluses, CAFO permitting, frac sand mines, and more. The list stretches into the unknown future. The issues are both chronic and acute, with drivers that change both quickly and slowly. Given the nature of these disturbances, I wondered, will local experts be able to adapt conservation and planning policies to sustain the unique multifunctionality of their landscapes? This practical problem requires us to think differently about how we manage these systems. Researchers and practitioners increasingly argue that adaptive co-management is a promising framework for sustaining multiple objectives at the landscape scale. Some of you may be familiar with a similar idea of adaptive management, which simply means re-evaluating a management strategy after seeing how it works for a while. Adaptive co-management is an abbreviation of adaptive collaborative management, and it is this collaborative piece that makes it particularly relevant to our case of mixed ownership, multifunctional landscapes. Adaptive co-management, or ACM for short, is an intentional sharing of decision-making power among and between stakeholder groups in a dynamic learning process. Thus, since adaptive co-management gives explicit attention to the connections between subgroups, many researchers have found it useful to think of ACM processes in terms of social networks. For instance, which groups have access to funding will influence what types of management strategies get implemented. However, most ACM studies use network concepts rather than quantitative social network analysis, or SNA. SNA models social relationships between actors, which might be individuals, organizations, groups, etc., using matrix algebra that can be visualized as the famous dot and line diagrams pictured here. I reviewed a large body of literature that has taken this quantitative approach to ACM, and I discovered most of them modeled social networks of individuals. However, I argue that if we are concerned about the connections between subgroups, we ought to find a way to model social networks of subgroups in our systems. So that's the approach I developed, and I think will be useful in many kinds of shared governance situations. But I had to adapt the ACM framework for use in mixed ownership landscapes. ACM has been used successfully around the globe in single ownership and common pool resources, ranging from parks to fisheries. However, few have applied the framework to mixed ownership landscapes such as those covering most of Wisconsin, in fact, the world. One reason for this lack of research is that private property rights create a rather rigid hierarchy of governance that are difficult for ACM to account for. So to translate ACM into more appropriate terms, I turned to Eleanor Ostrom's Institutional Analysis and Diversity, or IAD, framework for some governance vocabulary. Firstly, we need to clarify that governance refers to all of the decisions that impact a resource, and that actors make these decisions based on the rules in use that organize their interactions in a particular situation. Rules in use include rules, norms, and shared strategies, and we call these institutional arrangements, or just institutions for short. Governance thus includes more than just government with its formal administrative processes, but also landowners with their morning coffee rituals, and lots of groups and institutions in between. Ostrom argues that there are at least 4 levels of governance ranging from more to less tangible: operational, collective choice, constitutional, and metaconstitutional. These are nested by the institutions they each create. The operational level contains actors who actually use or manipulate the resource in question. Collective choice actors make institutions that these operators abide by. Constitutional actors make rules collective choice actors abide by, and metaconstitutional actors make rules for constitutional actors. This is the hierarchical vocabulary I was looking for, because in mixed ownership landscapes we've done a lot of research on landowners at the operational level, but less about the people who make the institutions they abide by. So I decided to look at the collective choice level actors. I called them rule makers and their informants, or, quote, experts for short. They make management plans and give advice to landowners, and these institutions translate constitutional level landscape policies into operational rules in use. Experts make rules about particular landscape functions like crops and forestry, which become their expertise areas. In a given landscape, an expertise area often has several experts associated with it, and the most influential of these experts drive how the expertise area stewards the corresponding landscape function. So, is there a better or worse way for these expertise areas to be connected through the social networks of their influential experts? Just as in the whole governance system, adaptive co-management at the collective choice level must share decision-making power between subgroups, and this social structure must be dynamic to respond to the fast, slow, enduring, and acute issues I described earlier. In my literature review, I discovered a growing consensus that systems have the highest capacity for adaptive co-management when their governance is structured and functions as a modular adhocracy. This means that subgroups cluster in distinct domains or modules that are connected by other subgroups, and these act as brokers between the modules. Modules can form around an enduring issue, like erosion from croplands, or around an emerging or ad hoc issue, like woody biomass harvesting. The ad hoc modules often pull from the enduring modules, but this is unlikely to happen without a broker who can catalyze this synergy. In this diagram, there are 3 enduring modules and 1 ad hoc module, and not all of them overlap. And in that ad hoc module, we would consider both forestry and biomass to be the bridging brokers. With such a dynamic structure, a modular adhocracy can sustain the multifunctionality of a complex system by responding to both enduring and ad hoc issues, getting the right information to the right people at the right time. In mixed ownership multifunctional landscapes, the subgroups that need to be connected are the expertise areas governing the functions themselves. So I went looking for modular adhocracies among the expertise areas in a county in the Driftless Area. I asked, Does the county's most influential landscape expertise network exhibit adaptive co-management capacity for sustaining a multifunctional landscape? In addition, true to the public service mandate of our funders and the Wisconsin idea, I also looked for potential to improve this capacity. So in a way, you are all participating in the ongoing research now, as I hope our conversations later will continue to unfold the answer to this second question, which PowerPoint has foolishly decided to number a second number 1. So, how did I do my study? Firstly, I chose a county that clearly represented my general interest in mixed ownership multifunctional landscapes. This is an aerial view of a typical portion of the Driftless Area of southwest Wisconsin. It obviously fits my category, since different types of resources are not only connected but juxtaposed within and across landowner parcels. One main reason I chose to study a county in the Driftless was because the most obvious multifunctionalities here are forestry and agriculture, 2 enduring resources that apply to most landscapes across the United States. In addition, as several of my introductory photos showed, these counties experience a variety of systemic perturbations that require complex responses from local experts. Bioenergy from cellulosic biomass is one potential development, and I had particular interest in studying how experts would respond to this. Several of you are very familiar with the Driftless Area, and I welcome your comments and questions at the end. However, I ask that you do not try to guess the particular county in which I worked, as I promised my respondents confidentiality and would appreciate your cooperation in honoring my commitment. Though many types of resource flows are important for successful adaptive co-management, for example, money, time, and staff, information flows are arguably basic to all of these. So, I wanted to know how information flows among the expertise areas in this county. To what extent does the pattern exhibit a modular adhocracy? Information flows between expertise areas through the individual experts themselves, so my primary form of data collection was one-on-one semi-structured interviews with 27 experts. However, adaptive co-management studies have shown that qualitative factors in the context also influence how the modular adhocracy structure functions. So I also interviewed 8 contextual stakeholders. I directly observed the landscape and several governance meetings while living in the county for 7 weeks with a local family. And I gathered descriptive content about the area through plans, meeting minutes, and books. And whenever I collected any form of data, I used the source to refer me to other relevant sources in a snowball sampling method. I also targeted some resources based on their apparent relevance to my study. And just briefly, I want to emphasize how important it was for me to live in the county I was studying, even for just a few weeks. Not only did I learn much more about the context, I also gained access and trust with respondents I would never have gained otherwise. Moreover, as I was representing the university, this helped rebuild trust between respondents and the university, a relationship that needs nurturing in nearly every location around the globe. I asked one of my respondents how I could avoid being a jerk from the university, and she replied, quote, "You've already done the right thing by living out here and talking to the right people," end quote. Interviews lasted between 1 and 2 hours. With experts, the main purpose was to solicit their information network, which took about an hour per respondent. But I also asked contextual questions to learn about their role in landscape governance and their opinion on bioenergy. The information network question had 3 parts. First, from which sources do you get the information you need as you make decisions about the land? And this gave me the name of the source. Secondly, what is that information about? And this gave the expertise area with which that source was associated. And lastly, how important would you rate that source's information on a scale of 1 to 3, where 3 is vital? And this gave the strength of the tie between the respondent and that source. So at the end of every expert interview, I had a list of 5 to 75 names. Most of these were individuals, but some were entire groups, and others were impersonal sources like websites. To capture the most influential network, I snowballed to interview only those individuals who were nominated by 3 or more experts. I also targeted a few respondents who were not nominated 3 times, but were otherwise considered influential. So I was able to interview at least 1 expert from each expertise area, which ended up being 27 people. Though I did not require this, my 27 experts were all professionals getting paid for their work in landscape governance. Some worked for government agencies like the Federal Natural Resources Conservation Service, or NRCS, the State Department of Natural Resources, or DNR, and the County Land and Water Conservation Department, or LWCD. Others worked for private nonprofits such as regional resource conservation and development organizations, local woodland owner associations, and crop consulting businesses. Most of them were male, and most were located in a central building called the Service Center. They had a median tenure in their positions of 8.5 years. My 8 contextual respondents were also mostly male, and many of them were retired counterparts of my other respondents. Some had continued to work in the county doing related things, and several of these interviews functioned as oral histories going back to 1980, which proved to be invaluable. A modular autocracy will be evident as distinct clusters of strong ties, bridged by weak ties and brokers. In social network analysis, brokers score highly on a metric called betweenness centrality, which simply means the node is important or central because it lies between other nodes. This is the social capital implied by the saying, all roads lead to Rome. The more roads or information pathways that must pass through a given node, the more power that node has to influence the nodes on either side. Thus, brokers or hubs are first to see potential threats and synergies, and they can play essential roles in mobilizing a modular autocracy. I used the SNA software UCINet to identify and depict the strength of ties and betweenness centralities of expertise areas based on my interview network responses. I also used InVivo 10 qualitative software and structured reflections to analyze the contextual questions and other qualitative data according to my frameworks. After interviewing all 27 experts, it became apparent 7 of them were not influential at the county scale and/or at the collective choice level of governance. I therefore excluded them from the social network analysis. Since the remaining 20 experts fit my criteria, I termed these the, quote, influential experts, and the 7 I excluded as the, quote, other experts. Though I won't have time to discuss them in detail today, the responses from the other experts were nevertheless crucial to my findings, as they shed further light on the context, and they provided a rare insight to the social capital available outside the bounded unit of analysis. Through my analysis, I discovered several interesting storylines that I outlined in my thesis, but today I'm going to give you the main thread that connects them all. We're actually going to work our way backwards through this causal chain, starting with my network findings, which are explained by an expert information-seeking heuristic, which is explained by contextual causes I discovered through my qualitative methods. Together, these explain how high, moderate, or low is the adaptive co-management capacity in this case study. So, I'll begin by describing the network structure and hints of its function. You've seen this picture before, and now I'm going to train you to interpret it like a social network analyst. This is a network diagram of how all of the expertise areas in this county are connected. There's a tie between 2 areas if they share at least one expert who has expertise in both areas. The strength of that tie depends on how prestigious is or are those shared expert or experts. I measured prestige by how frequently an expert was nominated and how important others deemed that expert to be for each nomination. A few notable features jump out in this picture that we will investigate in further slides. Firstly, I'll draw your attention to what is not there. The most influential experts do not tap information about planning, culture, education, energy, air, built infrastructure, recreation, or economic development information, which is an island. Secondly, notice the size of the nodes. This illustrates betweenness centrality, or that brokering or control over information flow we talked about earlier. Forestry, water, and crops have notable brokering capacity between different regions in this network. Lastly, notice the colors. These are marking detectable clusters or subgroups around these brokers. There are 3, green around forestry, blue around water and crops, and orange around the margins of these other 2 groups. Remember that we are looking for a modular autocracy. Are there clusters of strong ties connected by brokers? So let's see if these clusters of color follow the pattern of strong ties. If we filter the diagram to show only medium to strong ties, we see a remarkable spider-like structure emerge. There are 2 clusters, one in blue including crops, conservation, water, and law enforcement, and one in green, forestry, administrative rules, archaeology, endangered resources or ER, game, maps, biomass, and invasives. Respectively, these represent the agricultural and forestry modules, and they are connected by a single medium-strength tie between conservation and forestry. The other expertise areas in orange are no longer connected, which means information does not flow between forest ag and these areas at this level of interaction. Note that forestry and conservation are the information brokers at this level. If we filter the diagram even further to show strong ties only, we see that forestry and agriculture are no longer connected at all, though forestry and conservation remain the strongest brokers in their respective networks. Most of the expertise areas are not connected to each other at the strongest level of interaction. The remaining core of the agricultural module consists of conservation, crops, and water, which we might expect given the history of conservation in the NRCS since the Coon Valley Project of the 1930s. But the core of the forestry module consists of forestry, invasives, and biomass, which is new and surprising. Given the history of forestry in Wisconsin, we might expect it to be most strongly connected to something like game and recreation. This new forestry association between invasives and biomass provides some evidence of an ad hoc response to some of those changing landscape conditions I described at the beginning of the talk. This diagram shows the weak ties only, which reveals pathways for simple information flow. This shows that forestry and agriculture are actually connected by 7 direct weak ties and 3 indirect weak ties, so the two modules are not completely divided. The brokers here, crops and biomass, can turn these weak ties into strong ties if the context allows this flexibility. So we have to look at why these strong and weak ties form. In the next section, we'll look at why experts seek some types of information and sources more highly than others. But before we move on, we can summarize the network findings like this. Forestry and agriculture are not connected at the strongest levels required for collaboration, but they are connected by weak ties for coordination, and there is some evidence of a modular adhocracy. But it is not evident from the diagrams themselves if the system actually has the adaptive capacity to be flexible with these connections. This depends on the factors determining how experts seek and value information. So now we'll move on to the next step of the causal chain, the expert information seeking heuristic. During my interviews, I periodically asked experts to explain why they gave information sources certain importance ratings. Based on these responses, and on my direct observation and content collection, I discovered this basic outline of their common mental model, which I'm calling the expert information seeking heuristic. It has 3 tiers that determine how strongly an expert will value a given source. If a source is considered an expert in more than one expertise area, then this individual prestige will contribute to a strong tie between that expert's expertise areas. Firstly, faced with an information opportunity, an expert will ask, does a rule require me to get this information from this source? If the answer is yes, there will be a medium or strong tie between sources. Examples include an endangered resources lookup or stream crossing permit. If the answer is no, then experts ask a second level of questions, and there are 3 of them. Do I need the information? Do I have time? And do I have permission from my supervisor? If the answer is no to any of these questions, the expert is probably not going to get information from that source. If the answer is yes to all 3 of these questions, there will be a tie. The expert will get information from that source. But how much the expert values that information will depend on a 3rd level of questions. There appear to be 6 of them at least. Do I need the information often? Is the source in my building? Is the source otherwise available? Is the source trustworthy? Is this the only place I can find the information? Is the information timely, trending, or just in time? If any of these are no, then the expert values the information only a little bit in a weak to medium tie. If all of these are yes, then there's a strong tie, which functions the same then as a rule mandating the information source. The yes or no answers to all of these heuristic questions are determined by contextual factors in the setting. For instance, the supervisor's management style in large part determines if the supervisor will allow an expert to seek information from a given source. And now we move to the driving causes in my main story. My qualitative methods began to weave a story of landscape collaboration with a major turning point around the 1985 Federal Farm Bill. Before then, there were only 1 or 2 conservation programs for experts to administer. But the 1985 Farm Bill authorized at least 2 major policy changes that completely shifted the way local experts interacted. Firstly, the bill required cross-compliance so that farmers receiving FSA subsidies also had to have a conservation plan on file with the NRCS. This easily tripled overnight the amount of work for county NRCS staff, but county LWCD staff were able to understand the plans and collaborate with NRCS to get them done. But the 1985 Farm Bill also authorized the modern version of the Conservation Reserve Program, or CRP. This opened up a new era of modern conservation policy aimed at payments for individual practices, not holistic conservation plans. As the years passed, federal, state, and to some extent local programs proliferated, became very complex, and changed almost annually. These policy changes forced experts to become program specialists, which effectively built communication and collaboration silos that supervisors and staff had to work very hard to overcome. As John told me, when it was just 1 or 2 general programs, we were all kind of on board and doing it and helping each other. But as we got more and more federal programs, more and more state programs, then we found ourselves not being able to help each other, the agencies with their programs, as much as we were trying to cope with our own. I think as we got more and more programs, I would say no, it didn't bring the large group together more often or, more cohesively. It was probably just the opposite. Program proliferation inevitably turned field conservationists into paperwork administrators and long-term staff into grant-funded LTEs. This increased frustration while decreasing available time and trust for building relationships with other staff. Recent budget cuts have exacerbated staff turnover and shortages. As Alex told me, what I see as vital is having solid people in a position long enough they can build the bridges to effectively work and communicate with other staff. People are working the jobs of sometimes 2 and 3 people, and we tend to only interact when we absolutely need to through laws or programs or stuff like that because it's crazy what we're attempting to do. In fact, I didn't need Alex to tell me this. Staff frenzy and fatigue were evident to me as an observer. At least 4 experts declined interviews permanently because they were too busy for months. Interviews were constantly interrupted by ringing phones and people popping in, and some respondents were so exhausted during interviews they had trouble articulating their thoughts. Not only is this a swift path to staff burnout, it hinders adaptive collaborative responses to landscape issues. Being co-located in the same building helps with these challenges by increasing incidental interactions, weak ties, that can lead to strong ties. For instance, Peter narrated, when we're in the break room eating lunch and someone says, "Oh, by the way, NRCS is going to start funding this," the DNR and the county staff can hear that. If they have different office locations, it's harder to just pick up the phone, especially when they're just rumors. You're probably not going to call someone or even email them that. So communication is very much fluid and enhanced in this office because we're all in it. While this does promote collaboration within the service center, it also marginalizes those who do not work there. Expertise areas that are not represented in this building, such as planning, economic development, and culture, are included in collective choice decisions only by special invitation for large projects, such as watershed or countywide plans, if they're included at all. In previous years, experts were able to build a remarkable culture of collaboration despite these challenges. Their shared strategies included weekly interagency meetings, semi-annual social outings, and unwritten agreements to share staff and earmarked funds. Supervisors at the constitutional level supported these strategies. As one of my retired professionals, Jerry, related, "Frankly, I kind of got indirectly told that what John and I did in this county was good, because people knew it worked. We got a lot of work done. They said, 'What you guys are doing, just do it.' We don't want to hear about it. As far as a local workload day by day, my state office left me alone." But all of this has changed with staff turnover in the last decade. Weekly meetings and social functions have ceased. Trust is lacking in key working relationships between constitutional and collective choice actors. Attendance and dialogue at monthly meetings is less frequent and more guarded. Moreover, the conservation goals of resource professionals and the county board appear no longer aligned. In short, their culture of collaboration is eroding and being replaced by a culture of coordination through referrals. In this way, experts have transitioned from a pattern of interaction that was like a healthcare HMO to one that's more like a PPO. As John put it, I think we had the big picture when we had less programs. I really do. Now, Jonas explained, instead of trying to make myself an all-in-one, I'm just one of all, so I send landowners out to other experts. Program proliferation, staff turnover and shortages, changing supervisors, and the surface center island all contributed to this shift, but it seems that the driving reason behind all of these is a ubiquitous push for accountability or job security. To one supervisors, funders, agency directors, legislators, lobbyists, taxpayers, and to some extent, other experts themselves. Peter put it this way: WDNR and LWCD is a good interaction, but it's hard. It's hard because we each have our own programs and funding and everything, and our own missions that we do have to accomplish. We can't all be doing the exact same thing, otherwise we don't need to all exist. The net result is that experts today are less able than they were 30 years ago to communicate tacit knowledge across disciplines, and this decreases their adaptive co-management capacity and may even become a rigidity trap. Together, these 3 links explain that the adaptive co-management capacity of this expertise network is moderate. We can summarize the main story like this. The network data showed us that forestry and agriculture are distinct modules, and they are coordinating but not collaborating, and the forestry module seems to be ad hoc. The network and qualitative data showed these connections between expertise areas depend on how experts value sources of information. And the qualitative data showed contextual factors are limiting how flexible this information seeking can be. Thus, to answer research question 1, adaptive co-management capacity in this case is moderate. Yet the current capacity need not be the future. In answer to research question 2, interventions at the collective choice and constitutional levels could increase adaptive co-management capacity. Experts then have some power to improve their situation. These leverage points are listed in order of increasing leverage, also indicated by the increasing font size. First, make extra efforts to include experts not located in the service center. 2, hold weekly and quarterly staff meetings and semi-annual socials to increase awareness of each other's work and build trust. 3, use managers and veteran staff as champions of a culture of collaboration. And 4, foster leadership training and mentoring for generalists. And if you're here as a policymaker or policy advisor, these next 2 slides are for you. 1, increase the number of permanent staff for all roles, but especially generalists. 2, create office space for economic development, culture, and planning experts in the service center to overcome the spatial barrier. 3, consolidate conservation programs, not the approved practices or staff. 4, create a landscape governance bridging organization or group with a strong champion facilitator. 5, replace current accountability systems with interorganizational mapping database showing plans and practices accomplished. And this should be overlaid on a map of the county's multiple ecosystem services that is co-created by citizens and experts. 6, reform supervisor mental models to allow some staff to be long and short-term generalists. And 7, change the paradigm of landscapes from complicated to complex, including economic and cultural sectors. The network data reveals structural holes between forestry and agriculture that these actors can exploit to implement these interventions around a particular ad hoc project. My experiences and data suggest that the Driftless Area may now have the right people with the right skills and resources to weave these networks together around biomass harvesting during stream restoration projects. We've already noted the surprising connections between forestry, invasives, and biomass, which suggests some energy and flexibility for harvesting invasive woody species for biomass. What I haven't yet described are the incredible amounts of money, time, and energy being spent on trout stream restoration in the Driftless Area. Trout angling brings over $1 billion annually to the Driftless, but these streams need to be restored and maintained. Usually, this involves removing thickets of woody species such as box elder that crowd the banks, then fall into the streams, creating bank erosion. Without a viable biomass market, these thickets are nearly always piled and burned. You can see the smoke rising from these piles in the video I captured last summer in the county. When I asked experts for their opinion on the potential impact of bioenergy in the county, most experts were positive, and those who weren't were merely looking for it to become an economically viable management practice before supporting it. Harvesting box elder and other invasives from stream banks will never be terribly profitable, but it could get funded as a restoration strategy for the area's famous trout streams. By modeling this proof of concept, a restoration biomass adhocracy could catalyze other biomass markets. In the best of all possible worlds, it may break open the closing rigidity trap, enabling creative responses to other complex landscape issues, such as the ones I described at the beginning of the talk. In conclusion, the adaptive co-management capacity of this county is currently moderate, but there is potential to improve it through several strategic interventions that could be implemented around biomass harvested during stream restorations. These findings are both specific to this case study and instructive for others. For instance, it is likely forestry and agriculture exhibit a similar modularity in all landscape systems governed by resource-specific programs. However, the overall density and specific pattern of ties will vary based on case-specific variables, such as leadership, culture, and spatial location of experts. The potential to improve advocacy for a given case will depend on key individuals with the right skills in the right network positions to close those structural holes at the right time around the right issues. It is not possible, then, for a single national or even state policy to legislate advocacy for all cases. Instead, policies should build flexible accountability systems that enable local responses across agencies and expertise areas. This accountability lesson would seem to apply to all systems of shared governance, whether in conservation, universities, or our personal communities. In fact, I would argue that all of us would discover new opportunities by adopting a similar approach to the one I described here. We can think of and even quantitatively analyze our spheres of concern in terms of networks of subgroups. networks of people, ecosystems, buildings, and the intangible realities of rules and culture. The world must have its specialists, its distinct disciplines, and it is good to feel competent in these comfort zones. But the world also needs generalists, boundary-spanning social artists, who are gifted at bridging these subgroups and catalyzing dynamic synergy. But whether we are specialists, generalists, or some iridescent combination of the two, we risk becoming rigid and stagnant unless we look beyond our own identities and embrace relationships with those unlike ourselves. And it is in this spirit of collaboration I thank several people and organizations who made this project possible. I'm especially grateful to my advisor, Mark Rickenbach, who has modeled a father-like patience and an uncle's witty sarcasm throughout. And though I learned this lesson from so many people here, I especially acknowledge my good friends Gina Collignon, Caitlin Stack-Whitney, and Michael Harris, who showed me what it means both to love and be loved because of our differences. Thank you. Please feel free to also click on the link that viewed the question and answer time live on Wednesday, July 17th. And again, feel free to comment on the YouTube page or contact me for further questions.